Hello students, I am Madhukar Supin, Department of Chemistry, Vijayanagar College Hospital, VSK University, Bandari. We will start this quantum mechanics part 2 where the BSc third sem is concerned. Under this we will study the Compton effect. Compton in 1823 performed experiments to establish the particle nature of the radiation. You know the two natures of the radiations, one is wave nature and one is particle nature. Compton explained the particle nature of the radiation. What is the statement of this Compton effect? They will ask this question in the examination for usually 2 marks. What is the statement or what is Compton effect? If monochromatic, that means containing the single wavelength, X-rays were allowed to hit a material like graphite, the scattered radiations have higher wavelength than incident rays. This effect is called Compton effect. That means incident rays, you see the experiment here. These are the incident X-rays falling on the electron of the graphite. These are having shorter wavelength. Then this, when hitting on this, gives the scattered X-rays. This is having the wavelength higher than this incident X-rays. And this is the recoil electron. As this scattering is produced by the electrons, it was thought that it must be due to collision between the X-ray photon and the electron of the target, which result in the increase of the wavelength of the scattered rays. The increase of the wavelength of the scattered rays is due to the collision between the X-ray photon and the electrons of the target. And suppose lambda is the wavelength of the incident rays or h nu is the energy of the incident X-ray photon, then you know that by de-Broglie relation its momentum will be mass into velocity is equal to h by lambda or h nu by c, where c is the velocity of light, nu is the frequency of X-ray. Suppose lambda dash is the wavelength of the scattered ray photon or h nu dash is the energy of the scattered X-ray photon, then its momentum will be h by lambda dash or h nu dash by c according to de-Broglie. If mv is the momentum of the electron after collision, then by applying the laws of conservation of energy and momentum, we can say that increase in wavelength is equal to delta lambda is equal to lambda dash minus lambda, because I told that the scattered X-rays are having the more wavelength than the wavelength of the incident rays, so that lambda dash minus lambda have to take, that is nothing but delta lambda is given by delta lambda is equal to lambda dash minus lambda is equal to, according to some calculations it is found that 2h divided by mc into sin square theta by 2. This is taken as equation number 1, where theta angle between the incident and the scattered X-rays. This is the incident ray and the scattered X-rays. This angle is called theta. Delta lambda is called Compton shift because this was explained by the scientist. Compton is called Compton shift. Equation 1 indicates that the Compton shift of wavelength is independent of the wavelength of the incident rays. This is independent of the wavelength of the incident X-rays. Whatever the type of X-rays you have taken for the calculation, it is not depending on this. This is confirmed by comparing the experimental value of delta lambda with the theoretically calculated value by substituting the values of m, c, h and theta. Mass of the electron, velocity of light, Planck's constant, angle between the incident and the scattered X-rays. In the term on RHS here of the equation 1, the two values are found to be in reasonable agreement. That means the value calculated by theoretical calculation and the value calculated by doing the experiment, both are almost same. We have studied the Compton effect clearly, I think. Now we have studied de-Broglie hypothesis. It explains the dual nature of matter. According to de-Broglie, like photons, all material particles such as electron, proton, atom, molecule, a piece of chalk, a piece of stone or an iron ball, including microscopic and macroscopic objects. So electron, proton, atom and molecule, these are the microscopic particles. Piece of chalk, piece of stone or iron ball, these are the macroscopic particles or objects. Big objects also possess dual character, that is particle like and wave like. The wave associated with a particle is called a matter wave or de-Broglie wave. So in the examination they will ask this derivation usually or for 2 marks or 4 marks. De-Broglie relation or derivation of de-Broglie equation. The wavelength of the wave associated with any material particle was calculated by taking photon as follows. That means by using the two theories we can explain this de-Broglie relation. According to Planck's concept, energy is E is equal to h nu, equation number 1. According to Einstein's theory, energy is E is equal to mc square. You know that well-known equation, equation number 2, where h is the Planck's constant, c is velocity of light, nu frequency of wave, and m mass of the photon. From equations 1 and 2, we get by equating these two, both are in terms of energy. So h nu is equal to mc square. But you know that nu is equal to c by lambda. Then we can say that hc by lambda is equal to mc square. So this in this case, one of the c gets cancelled. We have the lambda is equal to lambda going to this side, or you take this on this side, then it becomes h divided by mc. This lambda is equal to h by mc. The mass of the photon is replaced by the mass of the material particle, and velocity c of the photon is replaced by the velocity of moving particle v. Thus, for any material like electron, we have lambda is equal to h by mc, becomes lambda is equal to h by mv. This is equation 3, and you know that this mv, momentum of the particle, is equal to lambda is equal to h by p. This is called de-Broglie equation. I told that where p is equal to mv, nothing but momentum of the any particle. There are two significances of this de-Broglie equation. One by one we can discuss now. The first is, although de-Broglie equation is applicable to all material objects, but it has significance only in case of microscopic particles. This is because the wavelength produced by a bigger particle, for example, you take this ball, a big ball, using equation 4, come out to be too small to be observed. The value calculated for this wavelength for bigger particles is very, very small. Only particle electrons, atoms, microscopic particles, etc. give an observable value of lambda according to equation 4. This is the significance one. Second is, de-Broglie equation is used in the construction of electron microscope, which is used in the measurement of objects of very small size. You know that the use of this electron microscope for the determination of movements or the position of the particles like electrons, photons, like that. So that can be the invention of this electron microscope is due to the explanation given by this de-Broglie. This is a very important significance of the de-Broglie equation. In the examination, they will ask this question usually for 4 marks. Explain de-Broglie hypothesis. For 2 marks, they will ask this only de-Broglie equation derivation. In the previous also, Compton effect usually in the examination statement is for 2 marks, explanation is for 4 marks. Okay, thank you. I hope you all followed this one.